Hello, good morning everyone, and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baripur. You can personally meet me at college premises, ground floor physics lab, or you can also send me a mail regarding your query on the topic that I have discussed at my given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@gisgroup.org. Students, I have a YouTube channel and I have already uploaded all the video as per your syllabus provided by West Bengal State Council. So you can go through that video lectures, and if you feel any doubt, you can contact me directly at college or mail me regarding your query doubt. So for this subject, I am your subject teacher. Now, the corresponding course pages are www.webscte.org and www.webscte.co.in. The syllabus for this subject, Basic Physics, is already uploaded in the university website. So students, you can directly download the syllabus from there. The link is given here. So the title of this topic is Basic Physics. It is under the category of Basic Science course, and it has a credit 3, 2 lecture per week and 2 practical per week. So this course is generally made for diploma degree students of first year, first semester. So all the branches except architecture, photography, multimedia and printing technology. So this, apart from these 4 departments, other departments have to study this Basic Physics course as their subject in first year, first semester. So as we have in our college only electrical and electronics and communication engineering, these 2 departments. So these 2 departmental students will going to study this course Basic Physics in their first year, first semester curriculum. Now, today the topic that I will going to be discuss is basically we will solve numerical examples on the topic dimensional analysis, which is under unit 1, that is unit dimension and measurement. So a prerequisite for this topic is basic mathematical knowledge to solve problems and knowledge of basic concepts science such as physics. The course objectives are: learn the use of dimensional analysis of any physical quantity as well as determine the dimension of any unknown physical quantity, and check whether any equation is dimensionally correct or not. The corresponding course outcomes are: students will able to determine the dimension of any unknown quantity, as well as they will able to check whether any equation is dimensionally correct or not. So these are basically considered as possible course outcome. So before going to start with today's class, I would like to remind you that what we have already completed in our last 4 class regarding this topic. So after completion of these 4 class, today I am going to solve number of numericals on this chapter, basically on the dimensional analysis. So what is called dimension? You know that the nature of physical quantity is described by the nature of its dimension. So when we observe an object, the first thing we noticed is the dimension. In fact, we are also defined or observed with respect to our dimension, that is height, weight, the amount of flesh, etc. So the dimension of a body means how it is reliable terms of the base quantities. So when we define the dimension of the quantities, we generally define its identity and existence. So it becomes clear that everything in the universe has a dimension, thereby it has a presence. Now in physics, so the dimension of a physical quantity is defined as the power to which the fundamental quantities are raised in order to represent that quantity. The 7 fundamental quantities are enclosed in a square bracket to represent its dimension. So basically we represent all the physical quantity in terms of dimension of length, that is described by L, the dimension of time, which is described by capital T with the square bracket, and the dimension of mass, that is described by capital M within square bracket. So the lots of other dimensions are also there. Rest are the dimension of electric current, that can be described as capital A within square bracket, and the dimension of amount of quantity can be described as mole. So a mole within square bracket. Adding further, the dimension of temperature is Kelvin, that is capital K within square bracket, and the dimension of luminous intensity is candela, that is CD within square bracket. So these are the basic 7 dimensions that we are going to use to define or to describe the physical quantity. So we have already learned that how you can represent a dimension of any physical quantity, how you will characterize this. So today we will solve lots of examples. So after today's class, it will be very easier for you how you will deal with that kind of a problem, and it will also cover or complete the last 10 years question on this topic, dimensional analysis. So it will be also very easier for you to understand how you will prepare for your exam and practice at your home. So those students have already missed last 4 class. I request please go through that class once again and then proceed with the today's class. It will be very helpful or easier for you to understand today's class. So now I will discuss lots of problem examples on this dimensional analysis and describe all the detailed steps that you require to understand to solve this problem. Now, the first problem, that is Hooke's law states that the force capital F in a spring extended by a length x is given by F equals to minus of kx. According to Newton's second law, F equals to m into a, where m is the mass, a is the acceleration. Now the question is, calculate the dimension of spring constant k. Okay, so here two equation is given to you and you are asked to find out the dimension of spring constant k. Now the question is, how you will solve this kind of a problem. In physics, the first thing you need to know that you don't try to remember each and every step when you're going to solve some problem. You need to understand the steps, the procedure, so that you can deal with all the same kind of a problem in very easier way. Okay, so here what I have done, so as it is given F equals to minus of kx, so from there you can write k equals to minus of f by x. Now as per Newton's second law, it was also given that F equals to m into a, and so you know, the first try to find out the dimension of force. So F equals to m into a, so the dimension of small m, mass, that is capital M to the power 1 within square bracket L to the power 0 T to the power 0. So you know, something to the power 0 that represent 1, and the acceleration is m to the power 0 L to the power 1 T to the power minus 2. So combining these two will give you m to the power 1 L to the power 1 T to the power minus 2. Now therefore the dimension of spring constant k can be written as k equals to f by x. So now you substitute the value of dimension of f and dimension of x, so that will give you m to the power 1 L to the power 1 T to the power minus 2, that divide by m to the power 0 L to the power minus 1 T to the power 0. So ultimately what you will get, solving you will get m T to the power minus 2. So that is the dimension of the spring constant k. So do you understand the procedure? First you have to equate, first you have to express k in terms of some other quantity, then you have to substitute the dimension of that other quantity, and you can easily find out the dimension of k is this. Next problem, problem number 2. Compute the dimensional formula of electrical resistance R. Now as you know, electrical resistance, that is connected with very much well known Ohm's law. So Ohm's law says that V equals to IR, where R equals to V by I. So since work done equals to Q into V, where Q is the charge and V is the potential difference, so R equals to W by Q into I. So that is equals to W by I square T, as I equals to Q by T. Now the dimension of work W, that equals to m to the power 1 L to the power 2 T to the power minus 2. So the dimension of R, that is equals to m to the power 1 L to the power 2 T to the power minus 2, that's into a to the power minus 2 T to the power minus 1. So ultimately what you will get, the dimension of the resistance, electrical resistance R, that can be written by as m to the power 1, l to the power 2, t to the power minus 3 and a to the power minus 2. Now the next problem, problem number 3. A calorie is the unit of heat or energy and it equals about 4.2 joule, where 1 joule equals to 1 kg meter square per second square. Suppose we apply a system of unit in which the unit of mass equals alpha kg. So the unit of length equals beta meter and the unit of time is gamma second, so that a calorie has a magnitude 4.2, alpha to the power minus 1, beta to the power minus 2 and gamma to the power 2 in terms of new unit. So how you will solve? You have to use the unit conversion formula here. Now what is the unit conversion formula? That is N1 U1 equals to N2 U2. Now you know the dimension of U1 and U2. So from there you can easily find out the relation of N2 or the value of N2. So here I have done the same thing, that is N1 into dimension of U1, that is equals to N2 into dimension of U2. So N1 into M1 to the power A, L1 to the power B and T1 to the power C, that I have considered, that is equals to into M2 to the power A, L2 to the power B and T2 to the power C. Now what is given? 1 calorie equals to 4.2 joule, that is equals to 4.2 kg meter square per second square. Now N1 equals to 4.2, capital M1 equals to 1 kg, L1 equals to 1 meter, T1 equals to 1 second. So and M2 equals to alpha kg, L2 equals to beta meter, T2 equals to gamma second. So you have to find out the value of N2. Now the dimensional formula of energy is m to the power 1, L to the power 2, T to the power minus 2. Now A equals to 1, B equals to 1 and C equals to minus 2. So putting this value in above equation, we will get N2 equals to N1 E2 within square bracket M1 by M2 whole to the power A, L1 by L2 whole to the power B and T1 by T2 whole to the power C. Now substituting the value, what we will get? That's equals to 4.2 into 1 kg per alpha kg whole to the power 1, 1 meter by beta meter whole to the power 2 and 1 second by gamma second whole to the power minus 2. So solving and rearranging, what we will get? We will get the value of N2 will be 4.2 alpha to the power minus 1, beta to the power minus 2 and gamma to the power 2. So it is easily shown here that calorie has a magnitude 4.2, alpha to the power minus 1, beta to the power minus 2 and gamma to the power 2. So this is the solution of problem number 3. Next problem, that is problem number 4. Convert 1 neutron into dyne using the method of dimensional analysis. Now first of all you need to know the dimension of force. So the dimension of force, that is equals to m to the power 1, L to the power 1, T to the power minus 2 within square bracket. Now considering dimensional unit conversion formula, therefore N1 into M1 to the power A, L1 to the power B, T1 to the power C within square bracket, that's equals to N2 into within square bracket m2 to the power a, l2 to the power b, and t2 to the power c. Okay, so now as it is given, you know that a equals to 1, b equals to 1, and c equals to minus 2 as per the dimension of force. So in SI unit, m1 is equals to 1 kg. In CGS, m2 equals to 1 gram. In L1 equals to 1 meter in SI, and T1 equals to 1 second. In CGS, L2 equals to 1 centimeter, T2 equals to 1 second. Now putting the values in the conversion formula, what we will get, n2 equals to n1 to 1 kg by 1 gram whole to the power 1 into 1 meter by 1 centimeter whole to the power 1, and 1 second by 1 second whole to the power minus 2. So that ultimately gives us 10 to the power 5 time. So 1 Newton is equals to 10 to the power 5 time. Next problem. The centripetal force F acting on a particle moving uniformly in a circle depends on the mass m of the particle, its velocity v, and radius r of the circle. So derive dimensional formula of the force. So all the relations are given and you are asked to find out the dimensional formula of the force. So first of all, as we know that force is proportional to m to the power a, v to the power b, and r to the power c. So first we have considered this. So in terms of equality, some proportionality constant will be there. We considered k is the proportionality constant. So F equals to k into m to the power a, v to the power b, and r to the power c. Now the procedure is you have to put the dimensions of each quantity in both left hand side and right hand side. So if I am putting the dimension in this above equation, we get m to the power 1, l to the power 1, t to the power minus 2 within square bracket, that's equals to, in right hand side, m to the power 1, l to the power 0, t to the power 0 whole to the power a, and m to the power 0, l to the power 1, t to the power minus 1 whole to the power b, and m to the power 0, l to the power 1, t to the power 0 whole to the power c. So ultimately we will get that's equals to m to the power a, l to the power b plus c, and plus c into t to the power minus b. So ultimately we will get that value comparing the power of both m, l, and t from both sides. We get a equals to 1, b plus c equals to 1, and b equals to minus 2. That means c equals to minus 1 and b equals to 2. Substituting all these values, we get f equals to k m to the power 1, v to the power 2, and r to the power minus 1. So f equals to k mv square by r. Now the next problem, that is the speed of sound v in a gas might possibly depends on the pressure p, density rho, and volume v of the gas. Using dimensional analysis to determine the exponents x, y, z in the formula, that is v equals to c suffix p to the power x, rho to the power y, and v to the power z. So here, that is what we will get, where c is a dimensionless constant. Now incidentally, the mk's unit of pressure are kilogram per meter per second square. Now equating the dimension of both sides of the above equations, what we will get? We will get L by T, that's equals to capital M by T square into L whole to the power x into m by L cube whole to the power y and L cube whole to the power z. A comparison of the exponents of L, m and t on either side of the above expression yields that 1 equals to x, 3 plus y plus 3z. So that means what we will get solving these two equation, x plus y equals to 0, and the above equation, what we will get, the value of x is equals to half. The second equation is that y equals to minus half, and finally the first equation gives z equals to 0. So hence what we will get, we substitute all this value and we will get v equals to capital C into root over capital P by rho. Now the next problem. A student, while doing an experiment, finds that the velocity of an object varies with time, and it can be expressed as equation v equals to xt square yt plus z. If unit of v and t are expressed in terms of SI unit, determine the units of constant x, y and z in the given equation. So as we know, the given equation is v equals to xt square y plus yt plus z. So dimension of the velocity v, that's equals to m to the power 0, l to the power 1, t to the power minus 1. So applying principle of homogeneity in these dimensions, terms must have the same dimension. So v equals to xt square plus yt plus z. So that means v, dimension of v must be equals to dimension of xt square, or that's equals to yt or equals to z. Now first equating the dimension of v with xt square, from there we can find out the value of x, that's equals to dimension of v by dimension of t square, that's equals to m to the power 0, l to the power 1, t to the power minus 1, then divide by m to the power 0, l to the power 0 and t to the power 2. So that means m to the power 0, l to the power 1, t to the power minus 3, that is the dimension of x. Similarly, when equating v with y into t, we get the dimension of y, that is equals to dimension of v by dimension of t. That means that's equals to m to the power 0, l to the power 1, t to the power minus 1, whole divided by m to the power 0, l to the power 0 and t to the power minus 1. So solving these two, you will get m to the power 0, l to the power 1, t to the power minus 2. So the unit of x, that is equals to meter per second cube, unit of y, that is meter per second square, and unit of z, that's equals to meter per second. Next problem. Express capacitance in terms of the dimension of fundamental quantities, therefore mass, length, time and ampere. So it is very easy. So capacitance C is defined as the ability of electric body to store the electrical charge. So capacitance equals to total charge by potential difference between two places, that is Q by V. So that means coulomb per volt. So as volt equals to work done by charge, that means it's equals to joule per coulomb. So capacitance equals to charge square by work done. So charge equals to current into time. So dimension of Q, that equals to A into T, ampere into T within square bracket, and dimension of work, that is equals to force into distance, that means mLT to the power minus 2 into L. So substituting all these value, we get the dimension of C, capacitance, that's equals to m to the power minus 1, L to the power minus 2, T to the power 4 and A to the power 2. So these are the reference book that you may refer or for your practice. So the evaluation process are same. Student have to appear for 20 marks mid-semester exam and end semester exam for 70 marks. attendance assignment tutorial for 10 marks. Hope all of you have understand today's class and enjoyed also. Next class I will solve same kind of lots of problem on the topic error analysis. Thank you.